So I'm Valerio. I'm head of data analysis at LCLS at the SLAC National Laboratory. So that's us. We are in Menlo Park, California. We accelerate electrons close to the speed of light, for some context, in that 2-mile-long building. Then we make them wiggle in the area nodes and ondulator. And when the electrons wiggle, they emit very bright, very coherent X-rays that we then focus in one of the 2 experimental holes on samples. Usually the sample is destroyed in this process, so it's really hard to replicate the experiments, but useful data is collected. And the division where I work, the data system division, takes care of the computing that does the whole pipeline. So we get the data from the detector, we perform some calibration correcting aberration and interferences from the electronics, and we save the data into files. This part is called data acquisition system, and of course it must be very performant and very reliable, otherwise the data is lost. Then we give the files to the scientists, and we don't do the science analysis, but we help the scientists install and run their software, and then they get, hopefully, scientific results. So the department that I'm heading is actually data analysis department, so it not formally should only concern from files to the scientific results, so only helping user install and run software. But historically, we have been providing software deployment and software stack for the whole process. And what I inherited was a giant Conda environment that was used for everything. And you can see there are some pretty big packages here, like Dusk, analysis packages like Dusk, or I don't know, Zero and Q, even some instrumentations like Prometheus and so on, but also a lot of packages like Camera Link Gateway or the one beginning at LCLS2 that are needed to talk to the hardware and the detector. And that's the real problem that we had with Anaconda, because some libraries and their dependencies need to be kept at a specific version because that's what the detector vendor guarantees, right? So you need to have this version to talk to the hardware. And because Anaconda is a binary distribution and the users want or desperately need, depending on who you ask, the latest versions of everything, we needed to find the newest packages, but compile against all versions of the libraries, and they were not always available on Conda Forge. So we ended up rebuilding a lot of packages ourselves, up to 30% of the packages, and those were like 90 packages, so we are like rebuilding 30 packages every time the environment was updated. So when I learned about Spack, that was like a revelation for me, because now I needed to only find packages that could be compiled with the latest version with the old versions of the libraries, which is a much bigger space. And I didn't care that it was source first, because I was building packages anyway, so I might as well build pretty much everything. And I have complete control over the version of everything. That's what I call the power of the spec, because the idea is, in my opinion, so brilliant that I don't understand why it's not ubiquitous in all the declarative package managers like Nix or so on. And building for source was easy with the builder classes and with Python, so it was easy to expand. So what I started working on was on the data acquisition system, which is the most critical part, because we like to live dangerously, and also because we thought if we could port this, then the second part would be easier. So this was a globally installed environment with possibly a binary cache, because it gets installed on multiple machines. But it was the environment with only the dependencies in a view, because the code itself for the data acquisition system was built from source in a target directory and activated several times per day. More on this later. So this was not negotiable, because the people who develop this software at our lab are like old grizzly warriors, veterans of 1,000 battles, very set in their way. They have handmade written build script where they want minimal changes, so it was like not negotiable. We're working on the move, and several things work well. Like I said, we love the package classes, so goodbye to custom build SH from Anaconda. We love that it's Python. We can easily expand. We can add a version of a library just by subclassing the class itself. Robert, who's here in the audience, taught me this trick, and it worked perfectly, so thank you for this. And even when we had compilation error, I felt that I was fighting with the compilation error from the packages, not from the package manager. and it's much easier to find information on GitHub of why lib-A doesn't build with lib-B rather than it's a Conda problem that doesn't see the library because it's in environment and so on. What also works well is views. We make use of views to shadow or unshadow by including or excluding utilities from the system. For example, SSH in our system is compiled against Kerberos, so we need to run SSH from the system, so I just exclude it from the view. And I could even have different versions of dependencies in different views when people were testing new hardware. For us, it was a game changer when working with external libraries, especially CUDA, for which we had a lot of problems with Anaconda, system compilers, and the low-level libraries that are often provided with the hardware. And the community and support are fantastic with the Slack channel, and I think I felt very welcome. What worked mostly well, but with some problems, was the binary caches we found, this was some time ago, were too specific. We need to install on some whole system like Red Hat 7, again, because that what comes with the hardware and we can't change it. And when multiple people are building packages and writing to the same cache, it's a little awkward to share the private GPG keys, but we could work around that. And then when building against the environment, Conda already, if the environment includes the compilers, it will set all the environment variables for include and link in the libraries and the compiler. Spack doesn't do this, but it's okay. I mean, we modified the build script to just include this, but more on this later. Here, in this section where it did not work so well, no deal breakers, so we worked around all these problems anyway. The main problem what we had was the activation time of the environment. For us, it took 56 seconds on average. Now, it might have to do with our network topology, where some of the files are maybe, but even smaller environments take tens of seconds to activate.
That's our fault. We're working on that.
Okay. Now, of course, I could generate a build an activation script with a -sh, but I found the behavior a bit different than when I activate the environment. For example, when I activate my environment, now I see that something is set in the CXX and the environment variables, but it's CLang, which was one of the dependencies. This was quite surprising. So these activation issues are currently the biggest issues that we have, because, I mean, we generate the script with the activate -sh, but then we have to edit manually a few things. Like, for example, I know that Spack by default doesn't clobber the LD environment variables, but some of the packages do. For example, this is HDF5, and apparently some of the people working on our code don't use our link, or they use their own LD library path hex. And of course, this wreaked havoc on their build scripts. But this was almost a deal breaker in the sense that people tried it and said, no, I don't want to switch to this. My script doesn't work anymore, but I patched the packages for me with just 2 packages. And I had to patch several packages to build on Red Hat 7. Now, I'm not sure if it's supported or not, because I didn't find anything in the documentation that says that it's not, but also nothing that says that it is. Anyway, I also worked around this. So you're going to ask me, do you move to Spack? Kind of. So we moved to Spack already several small projects, especially development projects, most notably the collaboration we have on data compression with Robert. And we hope to switch to production before summer. But of course, we have to do all the rest of the work, and we can work on Spack only in the time that it's remaining. And because of this, we will have to live with a transition period in which this build script must work with both Conda and Spack. So we have a lot of conditions in the scripts. Now, you're going to ask me, what about the other parts? So I talked about the data acquisition system, but what about the data analysis part? So we decided to put this currently on hold, because our internal developed software will for sure be moved to Spack, but the user developed software is very difficult to move. Several packages simply depend on having a Conda environment for now. So they have dependency on Conda packages, and there's resistance from the users to say, we're not sure if we need to change this and so on. And also they don't like that it's a sort based distribution, and so if they want to update the libraries, it takes a long time. But I think this will change in the future, because currently we didn't provide, up until now, any GPU resources, but we are starting to provide them. So the users didn't use any GPU resources until now, but they are starting to port their software to use them now, and so they will appreciate that Spack makes this much easier. And also, once we move our tools to Spack, they will be encouraged to interface with our tools to also move theirs to Spack. But it will be a process in which we need to hold their hands a little bit and help them with building an installation script. Spack Develop and Spack Build Env and things like these are for now a harder sell. So most of these people, they have their own handmade software and build script, and scientific software. It's often a tragedy from the point of view of computer scientists, but which I'm not. I'm also a scientist, but contrary to most people, I've been a scientist. Let's say I ended up being a scientist even though I wanted to be a computer scientist, not the other way around. Anyway, so that's basically what I wanted to tell you about our venture in moving to Spack. And these are the people in my team who helped me testing the waters, let's say. And especially, it's great that Jana, the division director, trusted us to look in this direction. And so thank you. And if you have any questions, I'd be happy to answer.
Thank you.